Right, so this is on chapter 5, and is secure network devices. We're discussing firewalls, traditional firewalls, and then we're going into next generation firewalls. Next generation firewalls will be on the exam, CCNA, um, the CCNA exam. So I will read. A firewall sits in the forwarding path of all packets so that the firewall can then choose which packets to discard and which to allow through. By doing so, the firewall protects the network from different kinds of issues by allowing only the intended types of traffic to flow in and out of the network. In fact, in its most basic form, firewalls do the same kind of work that routers do with ACLS, which is access control list. But firewalls can perform that packet filter function with many more options, as well as perform other security tasks, because it's all about security. Figure 5.5, as you can see, shows a typical network design for a site that uses a physical firewall. The figure shows a firewall like the Cisco Adaptive Security Appliance, ASA, firewall, connected to a Cisco router, which in turn connects to the internet. All enterprise traffic going to or from the internet will be sent through that firewall. The firewall will consider its rules and make a choice for each packet, whether the packet should be allowed through. Although firewalls have some router-like features such as packet forwarding and packet filtering, they provide much more advanced security features than a traditional router. For example, most firewalls can use the following kinds of logic to make the choice of whether to discard or allow a packet. Like a router, IP ACLs match the source and destination IP addresses. Like router, IP ACLs identify applications by matching their static well-known TCP and UDP ports. Watch application layer flows to know what traditional TCP and UDP ports are used by a particular flow and filter based on those ports. Match the text in the URI of an HTTP request. That is, look at and compare the contents of what is often called the web address and match patterns to decide whether to allow or deny the download of the page identified by the URI. The stateful firewall feature provides the means to prevent a variety of attacks and is one of more obvious differences between the ACL processing of a router versus security filtering by a firewall. Routers must spend as little time as possible processing each packet so that the packets experience little delay passing through the router. The router cannot take the time to gather information about a packet and then for future packets consider some saved state information about earlier packets when making a filtering decision. Because they focus on network security, firewalls do have some information about packets and consider that information for future filtering decisions. Security zones. Firewalls not only filter packets, they also pay close attention to which host initiates communications. That concept is most obvious with TCP as the transport layer protocol, where the client initiates the TCP connection by sending a TCP segment that sets the zinc bit only, as seen in figure 1 through 5 in chapter 1. Introduction to TCP IP transport and application. Firewalls use logic. They use logic that considers which host initiated a TCP connection by watching these initial TCP segments. To see the importance of who initiates the connection, think about a typical enterprise network with a connection to the internet, as shown in figure 5.6. Firewalls use the concept of security zones, also called a zone for short, when defining which host can initiate new connections. The firewalls have rules, and rules define which host can initiate connections from one zone to another. All right, we're going to move on to next generation firewalls after we just go in brief about intrusion prevention systems, which is IPS. Traditionally, a firewall works with a set of user-configured rules about where packets should be allowed to flow in a network. The firewall needs to sit in the path of the packets so it can filter the packets, redirect them for collection, and later analyze them or let them continue toward their destination. A traditional intrusion prevention system can sit in the path packets through the network and can filter packets, but it makes its decisions with different logic. The IPS first downloads a database of exploit signatures. Each signature defines different headers, field values found in sequence of packets used by different exploits. Then the IPS can examine packets, compare them to the known exploit signatures, and notice when packets may be part of a known exploit. Once identified, the IPS can log the event, discard packets, or even redirect the packets to another security application for further application examinations. A traditional IPS differs from firewalls in that instead of an engineer at the company defining rules for company-based applications by port numbers and zones, the IPS applies the logic based on signatures supplied mostly by IPS vendor. Those signatures look for those kind of attacks. DDoS, worms, viruses. Moving on to next generation firewalls. This will be on the exam. The CCNA 200-301 exam topics mention the terms firewall and UPS, but preface with the term next generation. Around mid-2010, Cisco and some other competitors started using the term next generation when discussing the security products to emphasize some of the newer features. So with next generation firewalls, it's basically just new features. That's really what you need to know for the test. In short, a next generation firewall and a next generation IPS are the now current firewall and IPS products from Cisco. However, the use of the term next generation goes far beyond just marketing label. The term emphasizes some major shifts. Some of the changes that have required new security features include the proliferation of mobile devices that leave the enterprise, connect to the internet, and return to the enterprise, creating a new level of risk. Also, no single security function or appliance, firewall, APS, anti-malware can hope to stop some threats. So, the next generation tools must be able to work better together to provide solutions. In short, next generation products have real useful features not found in their predecessor products. As for Cisco products, for many years, Cisco branded its firewalls as the Cisco Adaptive Security Appliance, but around 2013, Cisco acquired SourceFire, a security product company. Many of the next generation firewall and IPS features come from software acquired through their acquisition. Next generation firewall still does the traditional function of a firewall, of course, like stateful filtering by comparing fields in IP, TCP, and UDP headers and using security zones when defining firewall rules. To provide some insight to some of the newer next generation features, considering the challenge of matching packets with ports. Each IP-based application should use a well-known port. Attackers know the firewalls will filter most well-known ports from sessions initiated from the outside zone to the inside zone. See Figure 5-8. The following list mentions a few of the features of an NGFW, Next Generation Firewall. Traditional firewall and NGFW performs traditional firewall features like stateful firewall filtering, NAT, PAT, and VPN termination, application visibility and control, AVC. This features looks deep into the application layer data to identify the application. For instance, it can identify the application based on the data rather than the port number to defend against attacks that use random port numbers. Advanced malware protection, NGFW, Next Generation Firewall, platforms run multiple security devices, security services, not just as a platform to run a separate service, but for better integration of functions. URI filtering, NGIPS. Note that for any of the services that benefit from being in the same patch, that packets traverse like a firewall, it makes sense that over time, those functions could migrate to run on the same product. The Cisco Next Generation IPS, NGIPS products have followed a similar path as the Cisco Next Generation Firewall products. The Intrusion Protection System first added these features primarily through its SourceFire acquisition in 2019. And IPS compares the signature-based database, which lists known exploits to all messages. It generates events, often far more than the security staff can read. The staff must mentally filter events to find the proverbial needle in the haystack, possibly only through hard work, back experience, and a willingness to dig. Okay, so we're reaching the 14-minute mark, and I didn't want to go over 15 minutes. So let's go back to, do I know this already? This will be on the examination, the CCNA examination. And It says, do I know this already quiz? It's 1 through 6. And in regard to next generation firewall, this is number 5 on that topic we just discussed. A next generation firewall sits at the edge of a company's connection to the internet. It has been configured to prevent telnet clients residing in the internet from accessing telnet servers inside the company. Which of the following might be a next generation firewall used that a traditional firewall would not? So next generation firewall goes above the traditional firewall. And we're dealing with applications, mobile applications, new technology. So B is the correct answer. Match, message, application, data. So we went over 15 minutes, a little bit, which is fine. This is a topic on security network devices. I will be doing this every day, except for Mondays, I'm off, for 365 days. So please join me as I go along and read throughout these CCNA books. This is Wendell Oldham, CCNA 200-301, Official Cert Guide. And I hope you join me to go throughout this journey going towards each topic. Thank you for watching. Thank you for subscribing. And thank you for going throughout this journey with me. I wish you well.